Okay, we're going to work on a bunch of junk here for Keith. How's that shovelhead coming?
Another month or so.
I heard that last year.
Yeah, you heard it 3 years ago.
Oh, that was me.
Oh. Yeah, that's right. I'd asked when the motor's going to be done. That was 3 years ago.
I'm working on plug wires, oil lines, and brake line. Okay, what's first? We'll do this. So we got the crimp pliers. See, go buy those online. Do your own. So you gotta get this on there first. Snot it up a little bit. Doesn't want to release.
Tighter than a frog's pussy.
Can't say it on the video.
I've heard you say a lot worse.
Not me. I would never say that.
You and everybody else.
No way.
Or maybe I was dreaming.
That's it. Terrible thing to say. Frog had feelings. Now I'm dirty. Alright, so we just pull off a little bit. Don't cut all the way through. That's your minimum knot. Cut off the excess, but don't cut the black part.
Not that you've ever done it before, right?
I have never done that in my life. Okay, you fold that back on itself like that. As long as you got a little bit like that hanging over the edge, you're good. So we take this, stick it on there. Now, the little wire, as you can barely see, is actually what conducts electricity. The black part just holds it together. Okay. It helps if you compress this lightly. Get it bending in the right direction. 1-inch plier. So the part that wraps it around goes on the split part. In the middle. And squeeze. When you hear the knuckles pop, you're good. So you're on there, sticks out the back side just a tick, it's fine. So that grabs a hold of the wire there until it rips it off. You should be good. All I can do is somehow get this to slide.
Yeah, just leave it there. I'll mess with it when I get home. That's right.
This side's coming out.
Yeah, leave it. I'll mess with that at home.
Straight. Cool. See, testing your thumbnail, see how strong it is. There it goes. Somewhere down that area is about where they sit. One down. Should make you do it. You screw it all up. Trick is not to script that monument filament in there. Not enough. too much down there. So you go too much, it looks like that. Then it gets harder. That one's still in there. That's good. The problem is this is an 8mm boot, 9.3 plug wire.
Tight fit.
Yes.
You don't got to worry about water getting in there.
When it starts to slide easily, it's time to quit. You're getting there. If you still got blood in your fingers, you're not working hard enough. All right. So you know how to do that now?
Yep. Blood, I thought that was assembly lube.
It was what?
I thought that was assembly lube.
Could be. A test spark plug? You got one of those at home?
Yep, I sure do. You ground off electrode.
Okay. Brake line. So why do you keep shortening these up?
Well, the original one,
Still too short, so keep
no, I was going to use it on my performance machine caliper, but it ain't worth a shit, so I got a GMA caliper.
Okay, this is what?
Universal hydraulic flaring.
Otherwise known as a big dollar flaring tool kit. Actually works pretty good.
Yeah, it does. It's worked on my other lines so far.
So first you gotta crunch it like that, and you spread it with that one. And this holds it. Anything oily. I think it's still oily. I got CRC on them too.
Okay, wait a minute. You got to put the fitting on.
What fitting?
The one you laying right there.
I've done that before.
You were about to do it again.
Do I have to put it on the correct direction or can I put it on backwards?
Either way, it'll work either direction. As long as it's on there.
It's on there now. Okay, you stick through basic until it's flush is how you do it. Just kind of eyeball it. It helps if it's in too dark. See it. You hold that flat. Tighten it down a little bit. Put this thing in there. Make sure it goes in the hole. Like that. See how it mushes it. If it didn't slip, it'll be good. And if it slipped, it'll be a crappy job. When it quits moving, you're done. Don't need to force it.
Beautiful. Just like factory.
It doesn't go all the way because
Yeah, I
Doesn't like it.
usually just take a file and file it down.
you mushes the tube out unevenly.
Yeah, I just file a little, I'll be good to go.
Mm-hmm. You could put on a little in your vise and beat on with a hammer so it goes in all the way.
That's the Tatro method.
That's right. Steel hammer too. Don't screw around. I'm sure it won't hurt the flare any.
Not at all.
Or you just hook it up. But you gotta remember to put the nut on there,
Yeah,
the correct direction, not backwards.
that's a universal fitting. It'll go either direction.
So this is the one that you massaged on over here. I see.
Yep, that's the one you did, and I...
See those flat spots there? It might
Yeah.
leak now.
What?
There you go. It's a good thing it's got a flare on this side because it's going to need it. That's an inferior job. It's hard to get good help. Alright, so we're flying today. That's 3 things we've done already.
Yep.
Barely even cracked 5 minutes. Or 20 minutes. What's next?
I need you to mock up 3 oil lines, or cut them to length. Flare them and put a 90, if you can do it. If you can find your tool.
So we want to go to Harley
Yeah.
flare with hard line, not braided.
Yep.
So we have to find the line, the flare and stuff, the nut, and the tooling for doing it. And all that's around here somewhere. So we gotta find it. We'll be back.
Alright.
Okay, I dug out my tools. So this is the 37-degree flaring kit that we start with. And then that's what you wind up with. To make Harley stuff. That's what it takes. So you gotta buy this kit here. And then after you screw up those pieces, you have to buy this kit here to get the parts you need that you screwed up over here. Because it's cheaper to buy the whole kit than it is to buy one part. So this is what that started out as. Pretty close, huh? And these, this started out as. A little shorter, huh? So that got all cut down. And we had to make the flare to match the Harley taper, which is not 37 degree. So that matches that. It only goes on that far. I can't make it go up any higher than that. It's as far as I can make it go. I tried.
As long as it seals.
I agree, they wind up making them flatter. They won't go in. I call this my question marks. That's how you make them fit on the oil tank without sticking in the head too far. So they go like that. So this is 37 degree here. And this is the Harley angle here, which is probably more like 20 or something. I forget. It's a lot less. This is way too short. It should be made out of, I should have made it from bar stock, but you don't know what it is until you start making this stuff. And my problem is right now is I took this stuff and I cut the serrations down so it wouldn't mark up the steel very much. See, it doesn't mark it up hardly too much here. Which is great for steel, which is over here. Copper, it still puts marks on it. But copper doesn't like to bend too much. I tried double flaring copper, it didn't work very well either. It's pretty much a waste of money on copper. I haven't tried aluminum yet. And that's stainless sitting down there. There's a 20-foot length of it. And if you haven't bought stainless lately, especially in a straight 20-foot length, you don't know what expensive is yet. And of course that has to be delivered by a semi-truck, so they charge you up the ass for delivery. And this is thick wall, which is like, as I recall, it's like 35 wall or something, 36 wall. I want something pretty strong. Now I know better. It should have been a thinner wall, something in the 20s, so it would bend easier. But it won't kink as much. Of course, it probably won't bend very easy either. So we gotta do is find out if we can even flare it, because I bet you this is just gonna slide on that. There you go.
You know, I'm just
What do you
wondering.
What do you figuring how to do all this?
No, I'm just wondering if this is going to hit my rocker box. The whole tank.
Yes, it does. That's why I have to put the question mark on it.
It does. Well, maybe before you get started, I should go take a sample and see if it's going to interfere.
That's why you make them like this.
Is that a smaller one? Yeah.
See, with practice, you learn how to do this stuff.
And that's as tight as you can get it then, right?
You can't get that bent any tighter than that.
Oh, shit, because I might have some clearance issues. Damn.
They fit tight. Same problem they always have.
But, well, what I'm saying is before you get started, maybe I should take a sample, a question mark.
See how it makes it flattens out?
Right, right.
So you put a vise and crush it this way, which makes it square section, which makes it flow good, instead of being rectangular section, which doesn't flow very well. And this is chrome on chrome, which is always great. And that's how much distance you get.
Okay. Well, before we go any
good luck on getting any less than that, because I worked my ass off to get it that short. And that's about the shortest you can make it go.
Well, before we go any further, I should take that sample home and.
So what I'm going to do is I'm going to see if I can do steel or stainless. I'm going to flare one piece of it, see what happens. Now these dowel pins right here are here for a reason, because they go in here. At least they used to go in there. Because that's what allows you to bend it this sharp, because that goes right to there. The tool is holding over here for bending it. Bending tool.
You got a scrap piece of stainless? Because I want to.
Nope.
Well, what I'm saying is I should take one of those home and to see.
This goes in here like this, and that's how you hold it. See what the bends up?
Mm-hmm.
So when I first made them, they were this much longer. So you had to start cheating.
Yeah.
And I determined how to cheat it by putting a dowel pin in it.
Uh-huh.
And then I went with the fabrication show. I talked to the guys that make all this stuff, and they said that's how we do it. We put junk in there to cheat the length. Now this has been crunched since I did this, and now this won't fit in there. Now after you bend it, it gets pretty tight. You have to flare it. Flaring is a whole other problem. How do you hold it?
Can you make that tight of a bend with stainless, or is it going to be wider?
I haven't got a clue. I'm telling you, I haven't done it yet.
Okay, because I need to take one of those home to see.
So the other tools have to be modified to even do this.
Right.
You have a very long taper and no distance. That's why the thing has been shortened that far. But the problem is you shorten it, you're losing your grip strength. Now it's not just this length. You can remember I cut it there and here, so we actually only have that much holding power. And then of course I cut that down so it wouldn't be big deep serrations, so I took away even more holding power to make it work. And my guess is it's probably going to slip. But you don't know until you try it. And a stick wall stainless is even worse. It makes it even harder to do.
Well, I tell you what, so you don't have to butcher up that fresh piece of stainless. You want to hold off?
No, because I have to find out at some point.
Okay.
So we're going to butcher it. The first thing I do is deburr it. So I got my nice brand new deburring tool. stirs it a little bit. Squeegee's going to help. Now, I can't remember if I flared it. Well, I would have had to flare it after I did it because there's no way of doing it beforehand. But I don't think it's going to flare, so I'm going to go ahead and flare it right now. And we'll always cut it off and do what we need. Let's see, we need just this stuff here. Just like that. Let's see what happens. See what the chance of working are going to be?
I have no idea.
I'll give it 10%. How's that?
Oh, boy, that's not very good.
That's not very confidence inspiring, is what you're saying?
Exactly.
I know it's probably not going to work.
But you'll find out in a minute.
The only way to
So
find out is to do it.
that's right.
That is the only way to find out. This being a long piece of tubing doesn't help because you have to deal with the length. It's got a good bite on it. Now, something I haven't done before is put lubricant on it. So the best lubricant I got in the building is Tribodyne.
Most expensive too.
How'd you know?
Well, $100 a quart, yeah.
This one's 120. They got the three. I should get the 360. That way, I know I got the good stuff in. All right, we're gonna try the good stuff on there. That should increase the working about 20% increase now. So I'm gonna go with 30% chance. How's that?
Only because you're using Tribodyne.
Yeah, I know it makes it a lot slicker. So we're only doing a single bend too. We're not doing a single flare. I think it worked. Well, I didn't move it, so it's at the angle.
And that's a cut down dye you're using?
Crushed the tube though. And it split the tube.
Did it split it?
Yeah.
Wow, that ain't good. So much for that.
I just need to get the deburr better. I had the same problem with copper and other stuff.
Hmm.
Back over here. See the camera.
Wow.
Oh, that's a blow up. So, I crushed the tube on the diameter. Right there, so it's oval shaped. I felt it doing that.
Looks like I'm going to be using
And then you can see the split in it a little bit. So you have to have no burrs on the surface where you're going to split the tube. So I've had that problem with other stuff I've done. You can feel the sharp edge on here where it wasn't deburred very good.
Oh.
So anyway, that was that sample test. Okay, give me the chop off tool over there.
What's that?
It's that big red thing.
This thing.
All right, here I'll trade you.
Okay.
So the way you find out how the stuff works is by actually doing it. See.
I think I'm going to go with a regular steel tubing after seeing
And I haven't
results of that.
I haven't done this for a while, so I don't even remember how I did it. that is not very happy on a cutting part. I think I wasn't
Getting a little hand cramp there, huh?
Well, I am holding it pretty hard. You can't see it, but
You need Scooby to hold it for you.
I'm actually got my gorilla strength on top of that thing for about a minute and a half, 2 minutes. Alright, so there's what it looks like now. Okay, let's go see what it looks like on that. Back up. Here. Yeah, it'll work.
Just got to keep it from splitting.
Yeah, it only split right on the... They didn't split all the way, it only split lightly. I don't even see the split here, but... On this side it looked like it was split. I can see it. I don't see no split. Nope, no split. Oh, looks good. Not very flat, but when you blow it up, it ain't very even on the taper.
I think I'm just going to go with the regular steel. Just
None of them are. Next problem is, what's the idea of this thing? Oh, you just give up too easily.
that's right.
I spent
I'm a quitter.
I spent a couple weeks trying to make this crap work. Okay, this is 23, 25 wall. See, I didn't know how thin this stuff was when I bought it. This one's 28 to 23. After you formed it. This end you can't tell because it's got a tape on it. But it's 32 on this side, but it's got a chingus on it. What's the ID? 320-ish average. It's actually bigger than this one.
But the question is, how tight of a bend can you get? And that's...
See, that's 317 there.
Yeah. That's going to be critical for me.
So this has opened it up a little bit. It's probably bigger than 3/8 right here. No, but still 3/8. That's weird. It's thicker wall tubing, but when you're done, it's better. It's got a bigger ID hole than the thin stuff. It doesn't make sense.
Yeah.
It doesn't make any sense at all, but so that could form on there. So I think it can be worked on. Fits in there nice. So, except for this part here, you know, I tightened the piss out of it, that's why I did that.
Well, like I said,
But it didn't do it on the
clearance
steel
is going to be an issue, so I might go with the regular
Well, you
steel.
have to go check this to see
Yeah.
if it works. It doesn't matter, that's as much as I can bend it. It
Yeah,
doesn't matter
well,
what material it is,
And
that's as much as I can do.
you'd be damn lucky to get the same bend on the stainless.
But this here would work for making that stuff work. So this is basically a little test piece for
Stainless.
putting a hose on and put a clamp on it.
Yeah.
You have to flare the end of it a little bit to give it something to bite on, but, so it wouldn't slide off. So, all right, well that's our test piece. So you're gonna take this home and do a play-in with it.
Mm-hmm.
See how that works. So you got that piece to play with, and you got this piece over here to play with.
Mm-hmm.
See how that works, and you bring it back, and we'll see what it does.
Yeah, take it from there.
Meantime, I'm gonna have to remember how to do this. Maybe I'll go watch one of my videos.
One of your old videos, huh?
The 36RL WL video series. That has me doing
Oh.
all of this work on there.
Is that the one where you spent all day bending them lines?
That's the one I worked on for 5 years back there. I don't know how many thousands of dollars I spent to make lines for that bike that he didn't want to pay me for, but and he said it was a crappy job when I was done.
Oh man.
But anyway, it's good luck on making them. So
Yeah.
anyway, I can make really good question marks.
Yeah.
I'm good at that. Now, what I didn't do, I haven't made the bubble flare yet to go to the end here.
Mm.
I haven't figured out how to do that yet. That's what these ones are for, I think. I'm not even sure which ones do that. No, doesn't it? 3/8. I'm supposed to be able to do GM bubble flares. Push connect forming is what that says. The only problem is I have no idea how to do it.
No instructions?
Oh, there's some instructions there. You're supposed to read those? No. Why would you do that?
Well, you get bored.
Oh.
You want to do it right, maybe?
Here's the bubble flare. Metric bubble flare.
Mm.
Now see, that makes real sense. You got metric dies.
You don't work on no metric bikes around
We
here.
only have American pieces here. So I think these go with this. Okay, this must go in here. Okay, see now I'm starting to figure this out. Okay. See now you have to, there, that goes on there. So I can put this in here. And I can put this around here. And then somehow that's going to put some kind of a flare on. Now I don't know what kind of a flare we're going to get. So we're going to get a bubble flare. Whatever the hell a bubble flare is. We don't know what a bubble flare is. Okay, so now if that goes on there. Okay, it's going to squeeze it in that far. So what do you think we're going to get?
A bubble flare.
I'm not sure what a bubble flare looks like.
Looks like a bubble.
I think that's one where it goes dead flat like a flange.
Mm.
What I need is one that puts a bubble, a nice radius for like a line, like a hose clamp would, you know, clamp on a hose. So I don't know if that's what that would do or not. So we'll have to look up a bubble flare and see what a bubble flare is. Or we just take a piece of metal and just do it and see what it is. We got enough metal around here we can do that with. Got some good metal right here. It's pretty bad. This is copper. Because he wanted to use copper for his bike. Oil lines first.
Mm.
I couldn't do it. I couldn't. See how it just kinks everywhere?
Yeah.
I couldn't stop it from kinking. Of course, he didn't care about me spending the $200 on a copper line. He didn't have a problem at all with me buying the line.
Just had a problem paying you though, right?
He didn't want to pay anything. That's the problem. If he's watching, he knows who he is. Then he accused me of sabotaging his bike there at the end. Gives you a nice warm and fuzzy feeling. You know what? I'm going to just go down here. There ain't nothing here that's round. Okay, I should be able to hold on to it there, right?
Yep. Oops.
We're going to cut off a $15 piece of copper here. Alright. Boy, that's going to be a gotcha moment there. Put this right here. That is trying to get me. Much better. There, I bubble flared it. Do you like that?
Yeah. It's like a crushed flare.
I'm gonna make something with this. Oh shit, how am I gonna hold on to that? Oh, that is gonna be interesting to do. Oh, I know how to do it. That's what they make a 6-jaw leg chuck for. I knew I had this leg for a reason over here.
Yep.
You know what else it can do?
It can hold copper line.
It can straighten the line. The tubing, because it's got 6 jaws. I don't know what I just did, but it didn't look like it did much. But I felt better doing it. Okay, I'm going to cut off a piece of this crap. Damn, that's a whole piece that disappeared. Lost my deburring tool. I need a deburring tool. Somebody stole my deburring tool. Where is that deburring tool? Did I leave it over there already?
It's somewhere on the bench.
Somewhere, I know that. Is that over there? Here it is. Somebody put
I
it
told
up.
you it's on the bench.
Somebody put it in the wrong spot. That's what the problem was. How's that dark filming going?
Better with the light now.
You like the light?
I think the audience will like the light.
That's pretty strange. Oh, that's pretty damn nice. Look at that. Cut off another piece. I just tested to see if I cut off a piece of square stuff. I was able to. This stuff's soft. Oh, I know it splits real bad. Copper splits real bad. That's what it was.
See, boys and girls, that's how it's done.
Yeah, I don't know what the hell it was. Yeah, copper is a real bad splitting problem. That's what it is. Any kind of a sharp edge, it will just split. about as radius I can make it.
Yeah.
That's not very good. Oh, that's a crappy job. Who did that?
Scooby. I think you need a bigger file. It's kind of small.
That's called a half-mean bastard file. It don't screw around. Now it's too short to put a flare on both ends of that.
Wasted all that time for nothing.
You like a piccolo now, right? Now we're still going to find out what a bubble flare is. It's not a waste of time.
Well, at least you know what you can use a 6-jaw chuck for.
That's right. I do my Clinton. I had a thing that went like this once. Those are my tools. You gotta put your tools back when you're done so you don't lose them.
It helps.
Okay, so now we have a 3/8 bubble flare. Okay, look how long this one is. Okay, this is the thing that goes on the end of it. I think we're gonna have to, I don't know if we can do that. I know this tool is made to actually use these tools, so we'll have to extend it completely out. See, it just made it. Okay, which one do you want to do?
The good end.
Not sure.
Which good end?
Yeah. I think this is the straightest of the two. Okay, so if you make it straight, the problem is that the tube is the same length as the die.
This will be interesting.
Crush it down. Okay, now we're going to go ahead and run this thing up in there. These bubble flares take longer to do than the other ones. I see a new problem we're going to have. Tube's going to get stuck in there. Okay, it didn't move out that end and we just lost a 1/4 inch, so you know it went someplace. Now hopefully this tool will pull it out and not break the tool off.
Yeah. Oh, that doesn't sound good.
Is it under pressure?
A little bit.
Testing it. That's under some tension. Okay, let's see what we got. Yeah, so I told you he's going to put that tube in the middle.
And that, ladies and gentlemen, is a bubble flare.
See, that ain't a bubble, that's a flange.
Well, whatever you want to call it. It's,
a piece of it, you know what? So how are you gonna make that work? I guess it'll fit on a GM car now. So we know what a bubble flare does.
Yep.
Makes a flange. And that one's a nice little bubble on the end of it. Put your hose on. Alright, so theoretically, if we do that correctly, okay, we know it's going to bubble flare right against that side there. So see how much of it collapses? 1/8 inch worth. So theoretically, if you give it a little bit less than 1/8 of an inch, yeah. Okay, so this is going to go this way. Okay, 1/8 inch recessed in there now. Oh, I'm not even close to where it needs to be. That should be enough. Oh, it came out easy this time.
Yeah.
I didn't do anything.
It's an invisible flare there.
It's
What? Something didn't.
it's something.
Oh.
It's putting a little bit of a hump in there. There is a little bit of a hump. It's in the wrong spot. I want to be a lot closer to the edge. 375 right there.
Yeah.
380 back to 375. Okay, so it was working, but I got it in the wrong spot. So to do it correctly, just have to time it, see? There, I think. Gonna make the bubble right there. You have to have a little bit of collar protection and keep it solid and compress it. So right about in that area there. Should get me pretty close. See, everything's just kind of experimenting.
Yeah. Trial and error.
They might actually make something do that tool, but we don't have it, so we'll use what we got.
Or the directions might even tell you how to do it.
No, I lost the direction. We don't need those.
You threw them away.
Yeah,
You didn't lose them. You threw them away.
well, same difference. We didn't need them.
Yeah.
We're not doing the correct thing anyway, so it doesn't matter. We need instructions, so. Close enough. See, I didn't do anything. Oh, I know why I didn't do anything. There's no compression going on. Yeah. See, it's not compressing anything until it gets... This needs to be shortened way down to nothing. Because the height of the flare is going to be dictated by this. See that undercut they got?
Yeah.
So what I have to do, I have to put a piece of bar down in here and make it and time it so it's only like right this far. Then it would do what we want. It would bubble up just a little bit. And then I can make it do what I need. So I have to make a part to go in there. The problem is once you put it in there, it probably would never come out again.
Yeah.
But that might be okay too. But theoretically, I should be able to put a little bubble right at the end where I want it.
Right.
So it wouldn't come off. You just want to go in there like this far. You do that.
And of course, nothing like that comes with it, so you got to make your own, right?
You might be able to put like a little chamfer in here, might help you. I'm not sure on that. It's going to go until it hits here, see? So it's bottoming out. Where's the piece it made? I'm not sure how it made it. Squeezed it into it. It must not have bottomed out. It couldn't have. Yeah, see, it didn't bottom out.
Right.
There's no way it could have. It bottomed out against a part. So if you're jamming metal in there, if you put a chamfer like they did on this side, it would give you a little bit more, but the problem is staging it to work correctly. It's obviously not the right tool, so you can make it bulge, but you couldn't. It'd be hard to control.
Yeah.
But if you timed it just right, you can get what you need. All right, so we got this made. Where's my Harley tool at? Yeah, this is my Harley tool. Let's see here. Let's see if this will. I've had some issues before trying to make this work on this tool. Somebody screwed up that they put a knob in the middle of this thing. It's going to make it hard to do. So now what you do is too short, but if I cheat a little bit.
I'll try it without the piece of round stock in there.
What round stock?
Weren't you going to put something in there? Oh, you're making a different flare. That's right.
The Harley flare.
Yeah. I kept thinking you were messing with a bubble flare. Yeah.
So I tried to do a double flare here. That didn't work. Still got a little bit of Tribodon on the end of this. So.
It'll work for sure.
The problem with this is it likes to. Oh, now it's slipping. There we go. So it likes the copper likes to split. That was the problem I was having with the copper. Plus it crushes it just like the stainless, which doesn't make it very round. Okay, let's see. So I deburred it really well. And see how it didn't split?
Mm-hmm.
So I was able to make it not split.
Yeah, it came out pretty nice, actually.
Except you got this
Yeah.
piece of crap in the way. So if you do deburr enough, it can do
Get
a
a
nice,
decent flare.
it'll get a decent flare out of it. I was trying to do the double flare, and it's just not enough strength to make it work. See?
Yeah.
You get about halfway around to do the double. So, it'd be a lot stronger with a double flare. It's just a matter of trying to get it to do it. But you see how much I crushed the copper? See how small it is here compared to here?
Yeah.
I really crushed it way down. So, that's the problem with that. You couldn't hold it enough to make it do it. Look how much it screwed up the inside of the line with that bubble flare. That could be a loss
Yeah.
of flow.
Yeah. Could be.
But anyway, I was able to do a decent taper to that. So, the problem is getting a nut on there. It's not going to fit. It should be. There's a high spot in there. It's not going to let me get it through.
Yeah.
But anyway. Alright, so like I said, we can play with copper if you want to try doing copper, but it's pretty rough.
Well, I'm going to stick with the steel.
The only real way to really do any of this stuff is you need to pour material on the inside of it.
Hmm.
Which I don't feel like screwing around doing that. But this stuff here,
Oh.
Safeco. This is a little bit
Yeah.
different alloy than this one. This is like what they make the dies out of,
Oh.
Perksite.
Uh-huh.
This looks like Perksite, but a Safeco they call it. So this is a heavy zinc material here. Feels like lead though, but it has a different feel to it.
So you melt that down and...
It actually melts in water, in hot water.
Really?
Well, it's 158 to 190 degrees.
Wow.
So water boils at 212. So you basically melt this, pour it inside your tubing.
Mm-hmm.
You cap the end of it, pour it in there, and then you go ahead and
Make
after
your bends.
make your bend. It keeps it from collapsing, so you can make good bends. And then you go ahead and just put it in
Heat it
water,
up. Yep.
heat it up, and it all comes out in the water.
Wow.
And then when you're done, you just pour it into a little forge thing here, not forge, but I forget what they call the thing that goes into mold,
Mm-hmm.
and you make it into that again.
Well, that's pretty trick.
Yeah, these are two different alloys, but this one's a little bit different than this one, but they both do the same thing. And that's how you keep it from doing all this crimping, kinking.
You're going to have to make a video on that alone.
See, this whole tube from here to here, this is basically just all junk.
Yeah.
It's all screwed up. Now, I can probably jam something in here and bend it back up, but because I went through a lot of feet of this stuff trying to make. I probably wasted 10 feet of this stuff trying to make it work. Couldn't get it to work. You just couldn't bend the stuff adequately.
I'm
All
not-
right, well, there we're on that. So aluminum's probably going to be in between these things. I'm doing it. Steel has the right consistency and the right diameter. It seems to work pretty good. The stainless looks like it was going to be a little on the smaller side for some reason. I don't know why it did that like that. But if I didn't cramp on it so tight,
Yeah, you're not going to get a good flare.
that would help. But you see how little actual holding power I have.
All
I
right.
got that much. But it did flare pretty decently.
Yeah.
The tubing is definitely a soft tubing, so it's malleable, it works. And it didn't split or anything, so it fits in a nut real nice too, which is always nice. And it did give a nice surface on it. So I think the stainless could be probably made to work. You just have to play with it a little bit to make it do what we need. And I got to do a couple pieces anyway to remember how to get this.
Mm.
It's pretty much just do it all by foot. There is no real tools here. It's all triable air.
That's it.
So, but anyway, we'll play with that next time. You're gonna have to do some mock-ups, see if it'll fit.
Yep.
That's it for now.
Okay.